Hello, good afternoon, everyone, and welcome to our second webinar of our September Fraud Month series. Today, we will be discussing how to eliminate vulnerabilities in your omni-channel payment strategy with artificial intelligence and machine learning. Hosted by our friends from Riskified. We will hear from them on what they've seen in the market and how their solution helps prevent chargebacks, or at least mitigate against chargebacks. So if you want to just move forward on the slide, just some quick housekeeping. This webinar is recorded and it will be posted out on our websites for future reference. There will also be, you also have the ability, as always, to field your questions on the toolbar on the right-hand side under the questionnaire tab. Just type those in for us. We're going to try and take those as we progress through the presentation, and sort of hear from everybody and sort of have a collaborative session here and sharing that information out with you. So moving on to the next slide, I'm Cornelius Hatting. I'm the Director for Revenue Integrity. Been with ARC for the last 6 years in this role of overseeing our revenue integrity, but also those of our stakeholders. And with me today is Doug, who will introduce himself.
Hi, everybody. My name is Doug Nass. I'm the Director of Fraud Investigations here at ARC. Been doing it for the last 27 years, so hopefully we can supply some good stories to add on to Eyal's presentation. We hope you enjoy it. So on to Eyal.
Thank you, Doug. Thank you, Cornelius, and thank you, ARC, for hosting us. It's great to be here and speak. My name is Eyal Rab. I've been with Riskified only 10 years, not 27 years like Doug, but maybe I can share some information and help make it a bit helpful for everyone. So I think we're good to go. So let's start. Hopefully it's an engaging webinar, and feel free to ask questions. I'll stop, and unless time runs out, I'll answer all questions. So let's, start at the beginning, right? The online volume of travel orders and e-commerce is just going up, right? So online obviously is taking over offline, but I don't think it's a surprise to anyone. I think the exciting part is just the volume keeps going up now, especially after COVID, year over year. And it just creates a huge opportunity for all of the participants, airlines, OTAs, and all of the partners in this ecosystem, right? And not only is the volume going up and the opportunity going up, also the bar is going up in terms of customer experience, customer, service, and the competition, right? If you have a very good app, if you have a very good frictionless flow, then you're going to make more money versus someone who has a clunky process. And because of all of these, right, you don't want to invest so much time in the marketing, in the app, getting customers to your site, getting them to place an order, only to be declined at checkout because of an inefficient fraud process, right? And what we kind of see in the market still a lot of times is that in order to fight the fraud losses, a lot of good orders and good customers are getting declined for the wrong reasons, right? So we think that the false decline problem, declining a good customer, is much bigger than the actual fraud losses. And this is kind of the problem that machine learning is trying to solve on this fraud domain, right? And a lot of times what we see, and when you actually break down the problem a bit more, you say, okay, there's good customers getting declined because they're flagged as fraudulent. Fraud is going through because it's not getting caught. And when customers or merchants try to balance between the fraud and the false declines, right? They introduce friction and checks, and that could lead to a lot of abandonment, which again defeats the purpose of getting the orders through. And basically what machine learning, as I said, is trying to do is fix this problem, right? So from a business perspective, with a good machine learning implementation, and it can be internal, it can be external from vendor, right? Then you're going to maximize your sales, right? You're going to enable a frictionless path to purchase, and you're going to prevent fraud, right? And what I want to show here going forward is the effort it's going to take to implement to reach these business outcomes from a machine learning perspective, regardless of how you do it, right? Regardless of you do it internally, use an external vendor, just the path you're going to have to take. So let's start. Let's take a very simple example. This is a made-up example, and maybe Doug with 27 years of experience can already tell if this order is good or not. But if you only got these 4 data points, right? You have a passenger name with an email booking a $600 ticket from EWR to SFO and back. Would you approve this order, or would you say this is a good order, this is a bad order, this is fraudulent, this is not fraudulent, right? And what I expect almost everyone here to say is, I need more information. I need more context, right? This is not enough to make a decision, which is exactly what you're going to do on the fraud domain, regardless of how you decide to check the orders. You can do it manually, you can do it with the rule-based system, you can do machine learning. This is regardless of the technology, this is the domain, right? So let me give you some more information. And Dag, you can share some of the, your thoughts about if you were looking at that order and this information was provided to you, how would you look at it, right? There's a good frequent flyer status. It's a last minute ticket. It's a 1-day round trip. It has a proxy connection. It's an unknown device. The card on file is used. They're upgrading the flight, and the IP is in Japan.
Yeah, thanks, Eyal. Yeah, I would look at this, and the fact that it's a frequent flyer status is gold is awesome, and we can see that that's in green. The 1-day trip, round trip, that's a potential issue. But looking at a basic level, yeah, the last minute ticket would be an issue. The proxy connection would be an issue. The unknown device as well. The IP's coming in from Japan, so part of this looks really good, legit. The other parts are quite shady. I would have a tough time with this, other than seeing that an upgrade using existing points. If the passenger name is solo going, it's 1 ticket. The frequent flyer status is gold, using their existing points, no other passengers within the travel, I'd probably let this go.
Yeah. And this is exactly, again, this is the domain we operate in, regardless of the solution we use, right? It can be someone looking at this order manually, calling the customer. It can be the most advanced machine learning solution. It can be somewhere in the middle. This is the domain, right? And in order to make a decision, you're probably going to kind of say at the end, there's like 2 stories to it. It could be a business traveler connecting from a corporate VPN from Japan, booking an unexpected trip to San Francisco, or it's a fraudster taking over an existing account in order to monetize, right? And the decisioning is going to be based on the 2 kind of paths you're going to take for each direction. Again, this is not related to the machine learning. This is just a random order that comes into your system from a customer, and you have to decide whether you accept the order or not, right? And the process you're going to go through is like, can I make a decision? If I can't make a decision, do I need more information, right? If I need more information, what type of information I need? And if I'm going to get that information, what information am I really looking for this specific order, right? And as you go through that process, right, this is basically what you're trying to do with machine learning. You're trying to make this decisioning process where you have in your head, and Doug has been, for example, doing it for 27 years, right? And you guys are doing it on a day-to-day, This is the process that you're going to go through, and you're trying to use machine learning to imitate this process, and in a highly granular, automatic, and scalable way, right? That's the advantage at the end, right? If you do it well, right, then you'll get this outcome. But let's continue.
Yeah, I'd like to add,
Yeah.
you know, I can get around as a fraud, you know, thinking like a fraudster, what they really do. I can get around some of those data points, but I can't get around everything that you're doing. It's just not feasible for a human just to be following all of that. That's where, you know, you stepping in is going to bring up that castle wall that normally I wouldn't see.
Yeah, I think you bring up a good point, regardless of at this point riskified, is machine learning can take a lot more parameters into account versus a human. And when you use it well, it's also very granular and it takes nuances. Again, there's still very good fraudsters that are very good at getting through, but you're trying to minimize that. So where is machine learning today, right? 2022, Q3. Is it a commodity? Yes, meaning you can take paid open source cloud-based and implement machine learning models and decisioning very quickly. There is no barrier to entry. Can anyone use it? Yes, right? Again, if you have some technical skills, you can choose, you know, whatever you're comfortable with. You can take some data, throw it at a machine learning model, and you'll get some decisioning. Doesn't mean obviously that's going to be the right and most accurate decisioning, but it's a commodity, right? Now, is it simple to implement? Again, I think the analogy is like running a marathon is simple. The concept is simple, right? There's a race, you start to train for it 4 months in advance. You have to be very rigid, very disciplined, do what the plan says, right? Not get hurt. And if you don't get hurt, you can run a marathon. Now, there's a huge difference between the concept of running a marathon and actually doing it, because if you have to do it, the hard part is getting up early in the morning to run the, 17 miles 2 weeks before the marathon, right? That's the hard part. So that's a good analogy, right? The concept is pretty simple. The implementation is much harder. But let's break it down, because I think a lot of the people here will want to know, how do I do this? How do I implement this? Right? So how does machine learning work? So if I were to describe it as this is a webinar at a very high level, you have the following steps, right? You have the data, right? The order data that we saw before, the person with the Gmail $600 ticket with EWR to SFO and back. After that, what you usually do is you go out and you add more data points to the existing data, right? It's called enrichment, right? So an example would be like, okay, it's the IP address. Is it residential? Is it cellular, right? Is it known to be a proxy? That's an enrichment. You go to some service provider, it's called a data provider. It gives you more information, and you just have more information about the order, right? After you have the enriched data, right, you're going to use features, right? Features is basically, the way I think about them are basically answers to small questions you have about the order that are going to help you at the end make the big decision whether to approve or decline the order, right? An example would be like, is this a last minute flight, right? So basically a feature would be like, anything below 3 days is called a last minute flight, right? You can say, does the name match someone that has ever filed the chargeback, right? You could say it's a true or false. So you go back and you say, did I ever get a chargeback from someone with this email address or first name and last name? And then if you find it, you put it here. The reason is, right, with features, is that they encapsulate some domain knowledge around fraud, which you don't have time or you don't want to deal with in production in real time. You're basically saying, I checked, I made sure, I prepared it. Now all the model has to say is go to that feature, get the answer to my small question, and then the model will make the decision. Okay. Then we're going to the algorithm. I'll explain it later. Right. The algorithm spits out the model. The model is used in production to make the decision. Okay. Do we have any questions on the chat or not yet?
Yeah, I've got a question about your features.
Yeah.
You talked about, checking the system to see if a passenger name has caused a chargeback in the past. We've had scenarios where I know that a passenger, when they travel on company time, a corporate traveler, it's all legit. It's
Right.
when they turn to their leisure travel, we've had examples where that's where the fraud is. Doesn't happen all that often, but we have tracked that in the past. How would you guys be able to differentiate between the two? So you have multiple customers, and on the corporate side, it's all good, it's all legit. You have another customer who's being targeted on the leisure side, and it's going to be bad, bad, bad. How would you guys handle that? Would that be an exception, or?
No, that's a great question. So you're asking a concept, which again, this is exactly goes into the core of, the challenge maybe with implementing a good machine learning model. And basically, we have a whole set of infrastructure that links identities in many different ways, right? So basically, I'm the same person when I work for Riskified and when I travel personally, right? And my behavior could be the same as because I'm a person, or different from an identity perspective. So we have, for example, a whole infrastructure that is basically a big graph database that says, Eyal works at Riskified. This is his work identity. This is his personal identity. And in this, I've never seen a problem when his work email, for example, was used, but I've seen chargebacks on his personal emails and vice versa. I've never seen chargebacks ever. So there's a multi-step process even to get to that insight where basically you need to link identities, and then we run a lot of our infrastructure, for example, runs a lot of graph algorithms just to link identities, right? So that's kind of just to get to that small feature that says, hey, for example, any personal problems with this person, or any good, any problems with this person at all, which is something that's going to be like a small flat feature that says good or bad, you need to hold the whole IT infrastructure just to get to it, if that makes sense.
Oh yeah. We have a follow-up question, or that might be timely here, is what if the same fraud customer comes back in to your environment with new details, meaning maybe the first attempt was caught, no transaction was issued, but you've captured plenty of data elements. What if the same fraudster comes back in, he's spoofed a different, coming in under a different proxy, using a different credit card, he's changed a bunch of his details, but the passenger name happens to be the same, but everything else has changed.
Right. So the decision you're going to have to make at the end is this is this now the real customer or fraudster? And again, the short and maybe not good answer to it is that we have a ton of infrastructure invested in detecting links between entities and orders, right? So let's say they did everything well, they changed their proxy from a fraudster perspective, right? They changed their emails that they're using, so it looks like a different account. They even used a different credit card from a batch file, right? But they're still, for example, they forgot to use a script that changes the user agent and maybe the computer or the emulator that they use. So for example, it could be that we catch them because at that point, because the signature of the device is the same signature, because it says, hey, I'm in iPad, but when you check the depth of the JavaScript on the thing, you say, okay, he's spoofing the user agent. He's trying to look at it as if is a highly profitable customer using some sort of an Apple product, but actually is using an Android emulator that just puts the user agent, right? So you go to that granularity of detail to catch stuff. And you could say, look, if someone is spoofing the user agent, right? And he's doing it, and he forgot to use his time zone on the keyboard to change it, and we caught it, say, okay, this is a fraudster. He was trying to hide really well, but at this point, we know it's not the real person. So that's kind of a glimpse into what we do, right? And it's a cat and mouse game, right? The fraudster keep evolving and we keep evolving, and it's a never-ending game of what are they doing now? What are we seeing? But there's also stuff that is not even identity-based, if you think about it. You can say, look, we have statistical features that says, hey, credit card BIN numbers, for example, with a certain IP location. So you would assume that a Nigerian credit card BIN with an IP from, let's say, France is risky, you're going to decline it. Well, actually, sometimes statistically, we say, we've never seen a chargeback where the BIN number was a Nigerian issued credit card and the IP was from France, right? And because it was never, we see that there was no chargeback there, we can say this is actually a really good indicator to the order. Again, that's kind of like the layers of deep infrastructure you have to create to deal with fraudsters. But maybe let's continue and we can dive deeper into it as we go along. So again, let's look about we talked about the enrichment, right? Let's go about the enrichment. We discussed it a bit. I'll just go over quickly, right? So this is what enrichment would be like to that order, right? You'll go to an email provider and they'll tell you, we've seen this email for the last 3 years. The IP address of the connection is from a corporate IP. That's usually good because you assume people are not going to infiltrate a corporate IP and hide. It's a corporate VPN, right? That's a proxy. The number is the same number we have on the account for the phone. He flew from EWR to SFO many, many times before, so the routine isn't scary, right? And the credit card on file is actually a corporate card because you look at the BIN number and it's a business corporate card, right? But at this point, you're not making any decision. You're just doing something very dumb. This is the data I have. I go to external providers. This is what they return. Good. Now I have more information to analyze, okay? Now, even the simple process that seems very trivial, very simple, in order to do it well, you have to overcome these challenges, right? First of all, it costs money. You go to a provider, they're not doing it for the good of the planet, you pay them, right? It takes time to implement internally, right? There's usually an API call involved, meaning there's a software involved, and what you have to do is you have to code the call to the API, to the data provider, even if it's a batch file, get the data, right? Then from a business perspective, how do you know that even if you invest all of this effort, it's going to provide value at the end? What's your ROI? Maybe you're going to spend a month implementing this, the API call to get the data, or even if you get a dump, it's going to take you 3 weeks to run a pilot, right? Even if it's free, and you're going to find out that, hey, I didn't improve my decisioning using this data source because other data sources, for example, are more accurate, right? So I just spent a month and a half, even though I spent no money and it's all offline, to not get an ROI, right? So data enrichment has its challenges. Most of your arbitrating time, and you have to be really good at knowing where to place your bets, right? And then there's the time aspect of it. A data provider that was amazing for you last year doesn't mean it's going to do the job this year, because again, fraudsters learn, fraudsters evolve, and also consumer patterns behave, right? So if there is, an email you think is a very strong data point, but suddenly there's a breach of emails and a lot of account takeovers, suddenly the effectivity of the weight that you give in the decisioning to an email address has to drop down. So it's a never-ending process.
So question that I have for you is, again, things change rapidly. The fraudsters get educated. They start, figuring it out and so on. So how quickly can you change your rules in this sort of system? And can you do it yourself, or do you need someone from your team to assist in that?
So we obviously, we have some rules that are more business, but we implement machine learning models that are just, the machine learning model are just more granular. But we do it from our perspective, we do it 24/7. We have a team that monitors everything, and we adjust it in real time, because what we've seen in the market is that people are not able to dedicate resources to tweak it dynamically, right? Let me just silence them. I'm in the office, 1 second. There we go. So sorry, back to office life. So to answer the question, when we do it for our clients, we monitor it 24/7. We have a lot of tools to detect anomalies and patterns changes, and we do it on our clients' behalf. And I'll cover it because of our business model. But if it's not us, then you're going to have to do it. You mean from the merchant side and the airline side, from the OTA side, someone's going to have to sit there, monitor the models, and tweak them. That's kind of some of the challenges with machine learning.
And then there's obviously going to be a shift in who takes on the risk, right, of the losses. Yes. Yeah. Okay. Thanks.
So, staying with the data points and data enrichment, we've got a question. Which data points are the most effective to use in identifying fraud in airline ticket purchases?
That is a whole different webinar and a tough question to answer, because that's what machine, and maybe I'll show it after. For example, our machine learning models have between 200 to 300 machine learning features when they make a decision, and they're very granular. So it's very hard to say what's really important and what's not. Obviously, what you try to figure out at a high level is how fraudsters are monetizing the tickets, and kind of try to understand what they're trying to do. So Doug, like you mentioned, sometimes fraudster will try to take over someone's account, and then once they take over someone's account, they book 3 seats, right? Only 2 people get on the flight, and the account owner that their account was taken over never shows up on the flight. So what you would look for in an order with 3 tickets, for example, one order, 3 passengers, you would see, is there like a correlation between, the main passenger and the other passenger, same last name, different last name, or not, right? You could say, hey, you could look at routes, right? From an airline perspective, a lot of time we look at the route capacity, right? Because if an airline knows that they're filling around, let's take the normal routes, right? East Coast, West Coast in the US, where the flights are always full in the normal time, right? EWR SFO is a full flight a lot of the time, right? An airline in this case could over-decline anything that looks risky from their perspective, knowing they're going to fill the seat, right? And then they're not sacrificing their margins for a decline, even though it might hurt some customer experience, right? But where they really should focus on is their profitable routes, the routes that are not being, there's no competition for, and they make a lot of margins, right? A lot of time the routes to Africa, right? If an airline decides to fly there, they can make a lot of margin. This is where you really want to be granular about where, how can you get as many good customers onto the plane, right? From an OTA perspective, it's a bit, it's a bit different, but a lot of times what you see is you also have to take margins into account, right? If an OTA is paying a flat fee on the order and they're liable for the entire order, sometimes you have to like be really cautious about, sometimes you tweak the model according to the margins. But again, at the point, maybe I'm going around in circles a bit, but the point is there's a lot of factors that make a good order good and a bad order bad.
All right.
So let's go into features a bit. Again, features are basically, if you to think about it, you're encapsulating your domain knowledge into small questions that you can answer, right? So you look at the bottom right, for example, right? Feature, expensive last minute flight linked to risk. She's saying, okay, first of all, what's a last minute flight? Anything that is 48 hours from the booking to the flight, okay? And you're saying, okay, did I ever see anything that is related to this customer from a risk perspective, right? And you get an answer, yes or no. It could be yes or no, depending on a lot of factors. Is this customer, did it, whereas their account taken over ever, right? How old is the email? How good is the customer, right? Did they ever file a chargeback? Did they ever have something they complained about, right? But then you're saying, okay, it's a last minute flight, and this part, it's not risky, for example, right? Another feature would be like, we think that a lot of time fraudsters, it's very easy for them to create an email, right? And then they can assume an identity of someone, right? But how close is the name to the email? A lot of times what you'll see more simple fraudsters do is they use a name, but just a random email. So a feature would be like, how close is the name of the passenger to the email, right? And that could be a lot of distance algorithms used. And you encapsulate it, hey, the email matches, the name matches the email, right? That's what machine learning features are. Obviously, you don't do them without context. You're trying to basically answers and create answers to questions you think will be relevant for your decisioning on the order. Any questions on the features, or I'll just continue? Okay.
Actually, question, we have a rules-based system in place today that our fraud group uses to review orders. Does this activity still need to be done with an AI tool, or was that kind of answered earlier?
Yeah.
Just want to make sure it's covered.
I would say if you have a good machine learning solution, it removes a lot of the rules, right? You can still have business rules, right? You can still say, hey, I'm not allowing, I'm not allowing what would be a business rule. A business rule could be like, you cannot order a flight, for $15,000 after 12 p.m. because we want to review, someone wants to take a look at it, and after 12 a.m. there's no one to look at it, right? I'm just making stuff up. But if it's not a business rule, then basically you should use machine learning models. They're just much more accurate at the end. They're much more granular, and they're much more dynamic. They make decision, basically they adapt a lot of time in real time to the order based on what's going on in the field versus a rule-based system.
Thanks.
But features also have challenges, right? it's software, right? Even to say passenger name matches email, someone has to write the code to do the comparison. Even if it's SQL, it's still code. Then you have to store the features for the machine learning models to run on, which is storage. And it could be normal databases, graph databases, Elasticsearch. There's a whole stack of stuff that you need to prepare for the feature to be answered, right? I'll give you a very simple example. Time on site could be a feature. How much did the customer spend on the site, right? Maybe he was researching the flight for 35 minutes straight, trying to figure out what's the best way because he's planning his family vacation and he keeps moving around. That's usually a good indicator of someone doing, a good user trying to actually find a good flight. Fraudsters also learn it, and they've bought a lot of time automating the fake browsing. But basically, you have a lot of data coming in. Say, oh, the person visited this page and 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 this page. It's like, okay, this is great, but this is, if you think about it, at the end, I say, okay, these 15 pages worth 2 minutes. You have to encapsulate it into a feature that says 15 pages, 35 minutes on the page. It fits there. That's processing. That's storage. That's software, right? Then you have data science, right? What you find out with machine learning is you have a lot of features, and not all of the features are effective at the same time, right? So think about a feature that might be very important for domestic US flights, but irrelevant for international flights, right? So, it could be like the internet, whether the credit card is international or not on a US domestic flight might not have the same weight as whether the credit card is international or not, or tied to the source country or destination country in an international flight, right? So the data science team keeps having to figure out what's really effective, right? And even if they have the best idea to implement the machine learning feature that is going to make the model amazing, and it's going to reduce, fraud by half and increase approval rates by, 3%, you still have a lot of dependencies. You say, okay, I can do it, but first I need this data source, this database to be built, this features to be implemented, and it's going to take me 3 months, right? So this is where the last part is. The velocity is important, right? You can't wait to react 3 months to a fraud trend. There's a data breach in a certain area in the world. There's a fraud pattern where some attack is happening. You can't now wait 4 months until you have a solution to it, because then your fraud costs are going to go through the roof. So those are the challenges on the features part.
Neil, I've got a question. Or when we've seen fraudsters that do what I would call traditional credit card fraud with that compromised card that was so prevalent out there. But we've seen them switch also into the bank loyalty programs. So we've seen it in our data, them getting or attempting to get tickets on traditional credit card fraud. They're unsuccessful. We can see that a ticket got issued, but it was also voided. See that pattern, and yet that same customer name, passenger name, shows up again with a corporate travel agency that manages a bank loyalty program. So basically, we're dealing with account takeover of someone's legit loyalty account, and they're going to siphon off funds. Would you guys be able to spot activity like that if that were happening? So it's two different schemes, but at the end of the day, it's all fraud.
Right. So I think it depends. You're right. We definitely tackle these fraud patterns. Sometimes we're, successful. Most of the time, I would say we're successful. Sometimes they get by. That's just the nature of dealing in this industry. You can't solve, you can stop all fraud. The way you detect such patterns sometimes is you kind of linking to identities, right? So you're saying, okay, the fraudster is obviously grabbing onto that identity for a reason, right? They're trying this person's, identity, maybe because they took over their account, maybe they can, have a fake license, right? So that's the pattern they're trying to use. They're trying to latch onto that identity and just switch payment methods, right? Miles from the loyalty program or stolen credit cards. Once they start to attack it, what we do, we have this kind of feature that looks at how it's linked to past decline sums and fraud checks, right? So if a fraudster is trying to do it and do it usually they do it very intensively in a short time, you're saying like, this person is being targeted right now. I don't care at this point what the payment method is. This is a fraudster. I'm going to decline them. That's how you kind of defend yourself against a fraudster in this case, right? You figure out that they're latching onto the identity, and then at that point you're saying it's not a real user, it's someone taking over that identity. No matter what payment method it is, we're going to decline.
Okay, thank you.
Yep. I won't go into the algorithm a bit. I'll go a bit into it. It's not that important, but basically what does, this is the core part of machine learning, right? Is basically you tell the algorithm, look, this is my historical performance. These are my orders. This is the orders I approved. These are the orders that I declined. And these are the orders that came back as charged. This is your ground truth. Now, what the algorithm does is say, okay, this is what I'm, striving to get to. Now this, and then you tell them, by the way, this is your features. Here's a bucket of features. And it's, okay, what the algorithm does from us, from a machine, this is machine learning. You're teaching the machine, right? You're telling this is the core of learning. You're saying this is what you need to get to. These are your building blocks. Go and learn. What the algorithm does is it starts to look at the features and say, okay, what if I take these features, throw them, make decisions based on these features, and say, okay, that decision, how close is it to my ground set of truth, to the decision that actually happened in reality, right? And it does this time automatically, thousands of permutations until it says, based on this data and this feature, this is how you should use the feature, and it spits out the model, right? An analogy would be like if you have a rule-based system, it's almost like the machine will go through your rule set, right? Even though it's less granular, there's a lot of deficiencies in doing it with rules, and it would say, I ran through the rules, I optimized, I ran through 10,000 different combinations of the rule sets, and this is the best rule set combination to achieve this result, right? That's what the machine learning does, right? It's almost, it's a step that creates the optimal decisioning model that you use in real time in production to make the decision. And that's the advantage of the machine, right? You can deploy a lot of resources where a human will not be able to do it, and you get to the optimal situation for a given data set, and then this process keeps repeating all the time. You retrain models based on your existing ground truth. So you have a fraud attack, you're saying, okay, maybe I can, how can I retrain this model to attack, to detect this fraud, and you can do it automatically very quickly. Now, again, what is the challenge? Same thing, a lot of IT work, right? You want to train new models, you want to A/B test models, you deploy models into production. What happens if your production system falls down? Who monitors it, right? Then you're saying, okay, last minute flights get a different model, machine learning model than, flights 3 months in advance, right? So how do you segment orders into specific models? Your data science team obviously is the one that trains the model. They have to choose the algorithm. How much data do you have to train on? How fast is your feedback loop? You don't want to say, oh, well, I'm going to train the model, but it's going to take me 12 hours to train the model, or 24 hours. I'll come back tomorrow. and I'll see what happens, right? And the most important thing is the maintenance part, right? You have, in COVID, what was really interesting is because so many flights were canceled, suddenly there were so many last minute flights changes, and basically last minute flights for people flying COVID wasn't risky, because if you were flying, you're probably, risking getting exposed to COVID. And we almost had to say, well, like, in COVID, last minute is actually a good pattern, right? So you have to retrain the model for it.
What?
So,
How would this help with friendly fraud, first party fraud, which has become so prevalent in the industry? Could you walk us through a scenario how this could help in that?
So for us, the way we look at it is actually very realistic. A lot of times, if you look at the industry, you have the fraud part on the front end, and then you have the chargeback, representment, ADM part on the back end. But for us, it's actually pretty simple from our perspective. We say, okay, we thought this order was good. We approved it. Now, when it comes back as a chargeback or maybe an ADM, what we have to say to ourselves is like, given what we know now, do we think this order was still really good? Or do we think, it was so good, it's actually first party fraud, because there's nothing bad about this order that would make it fraudulent. So it has to be the customer that is actually doing first party fraud, right? And sometimes you say, you know what? When the transaction occurred, we thought it was a good order. Now that what we know, we know it's a fraudulent order. The customer is right. There's no sense in disputing. So because we make the decision on the front end, it's very easy for us to evaluate whether we should, this is first party or third party fraud. Now, if you do all of this hard work, again, no matter who does it, how they do it, right? There's the same amount of work to get to optimal results has to be done. You're going to look at something like this. And what you see here is basically a simple graphic illustration of a machine learning model that is presented really nicely. That's not how a computer works, but that's just the illustration. You have the green ones are good machine learning features. The red ones are bad machine learning features. The gray ones are in the middle features for this specific order, right? In order to go through a model, the model says, oh, this feature is bad, this feature I don't care about, this feature is good, and I didn't use this feature. It wasn't applicable, right? So basically, when you get to a very good machine learning implementation, every order has a bit of everything. Some good stuff, some bad stuff, some stuff that's not used, and some stuff that don't sway the decision. And then you apply granular thresholds, right? And then you say, okay, based on all of these good features, bad features, right, I get a score for the model internally. And if the score is above a certain threshold, which is also something you constantly tweak, the order gets approved or declined. Okay, so what I'm trying to show here is in the real world with good machine learning implementation, every order should be gray, right? You should have you're covering so many data points and so many edge cases that some of it are going to be good, some of it are going to be bad, but that's okay because that's the real world, and because you monitor it all the time, you're going to make a good decision. So if you do all of this, right, you're going to maximize your sales, you're going to have less friction, and you're going to prevent fraud. There is one caveat to this. Even if you do all of this, right, the size of your network and reach still plays an important part of it, right? When we look at our internal machine learning models, a lot of the features we implement, a lot of the models rely on our network size, right? Which is not only travel, which gives us actually a very, it helps us help our clients, right? Travel or not, because, Doug, I don't know if you buy on Prada, but if you were to buy on Prada, for example, right, I could link some of your patterns into your order when you order on last minute, right? Or booking or Agoda or trip.com, right? So back to your questions around fraudsters trying to, come back as different, identities. It also helps on another end understand who are the good customers. So it's a double, it's a double boost where you have a very big network where you can connect identities using a lot of the merchants, right? So I think that's something that really helps us deliver great value to our customers. And the only reason I'm able to talk about this is because we had to implement all of this for the last 10 years because of our business model, right? So I'm not saying that you should use Riskified, but I'm saying because of what we do, where we provide a liability shift solution for our merchants, right? We had to implement all of this. So everything I've shown you is what we do and a lot more, because when we approve an order, right, for our merchants, and it comes back as a chargeback or an ADM, we refund the merchant or the airline with an ADM the full amount of the order, right? So if we're not accurate, we're going to lose money, right? So our business model that gives, clients higher approval rates and lower fraud rates forces us to do this on behalf of our clients. You can almost think of it as an extension of your team, right? You're hiring probably the best fraud solution in the world to work for you, and they're liable for anything they approve for you. And we don't charge any money for orders we decline, and we commit to higher approval rates on an SLA. So again, the fact that we came to this business with this business model 10 years ago forces us to go through all of the steps I've highlighted here, right? And we have solutions for blocking account takeovers and policy abuse, right? When people abuse policies. And if you really want, you can download the nice report on the ROI we deliver for clients. That's not the scope of this webinar. I'm just happy to share the knowledge that, will help anyone here, pick the best path for them based on their business needs. So we have, I guess around 7 to 10 minutes for Q&A, and I'll be happy to answer them.
Thanks, Al. So yeah, everybody, if you still have questions, please feel free to put them into the question area, and we can get those answered for you.
Yeah, we do have, or it's more of an observation. Is going back to the email name. So the question or statement, the email name different, or when it's different than the passenger name, I don't think it's a big risk factor. Normally people make their email with different words, and true, we see the same thing. But it's still an element to take into that you can process. If you see, especially if you've seen that email address used in bad transactions through another one of your merchants, right?
Yeah, this was more of a webinar example explaining how machine learning works. For example, so it was a very easy feature to explain. But for example, last month we saw a very interesting fraud ring where it wasn't attacking travel necessarily. It was more attacking some physical goods merchants. But what they were doing with the emails, it was Gmail domains with random strings, right? So there was nothing similar between the emails, but in general, they were connecting from the same IP location in the US, and it was always between an 8 to 10 digit, like random string, like you would see with a password generator, and we caught that, right? So the combination of the IP from the East Coast, it was, Southeast Coast, and these random emails were detected by our anomaly detection, and that fraud was stopped. So we knew it was like some sort of a bot attack that got credit cards. They had a way to, I guess, open emails on Gmail. If you open a Gmail account today, almost any single account you open, you have to provide a phone. So it's harder to create like randomized. So they probably were building a list of emails to use, but they weren't good enough in hiding, making the emails look real, because who would use an email that is, a Gmail that is random strings, and we caught that. Now, again, there's hundreds and thousands of features that over the lifetime you implement, and then sometimes you just let go because they're not effective anymore. And that passenger to email, as I agree, is probably not that important in the context of a PNR, of an order.
Thanks, Al. Another question in is, how is this different from 3D Secure? And is there value in adopting your solution in addition to the 3D Secure environment?
So 3D Secure does basically 3D Secure does something a bit different from a merchant perspective. It shifts the liability to the issuer. So basically the merchant isn't liable for the transaction anymore. So in theory, you achieve the same, I'm not liable for the transaction. The challenge with 3D Secure is basically that an issuer is saying, hey, I'm getting the same interchange rate, and now I'm liable for these transactions. So I'm not going to be as, as open with these orders as I can be if I wasn't liable. So they over decline a lot of orders, and there's a huge drop-off rate. So basically, a lot, especially in the US, implementing 3DS leads to drop-off rates where you're just losing sales because someone didn't complete the challenge, or the issuers decline it and you don't even know. You just get, oh, the consumer was declined. But any sophisticated merchant knows that 3DS, there is no free lunch. You implement 3DS, your approval rates overall are going to go up, are going to go down, because less orders are getting through, because again, the bank is going to be risk averse and decline them. But it's cheaper. You're not paying, it's kind of free, but it's not really free. It's a balancing act.
The cost is in your lost transactions.
Exactly. So it's almost a false decline problem.
The other question that came in is, do you guys look at any data across the dark web and bring that into consideration on your algorithms?
Yes. We have teams that look at it. I would say that even by the time it gets to the dark web, it's already being tested. So basically, I think the feedback loop we see is just dealing with, the amount of volume that we deal on a day-to-day just from the fraud perspective. So I think Riskified is a public company now, so the numbers are shared with everyone. Last year Riskified, was liable for $89 billion of volume going through our systems, right? So basically, we were on the hook for $89 billion of transactions. So if we made the mistake, we would pay the merchant back, right? Obviously, we're very good at what we do. So, right, we are, we make the right decisions and we give our customers the higher approval rate and loss rate, but this is just what we have to deal with, right? So, that volume that keeps growing helps us, fight fraud in real time, even usually before, someone posts it usually on the dark web after they've tested it and it worked for them. Hopefully not on our merchant base, but sometimes we learn it on our merchant base and then we see it on the dark web.
So another question from my side is, let's say it's a weekend, it's a Saturday or Sunday. there's no one in the office to monitor. Your solution is implemented. Is there any mobile alerts that's being pushed to the manager or someone or the owner's phone that allows them to act, and can they then, make decisions based on the information that's being pushed through to their handheld devices?
Yeah, so it's a good question. Riskified is fully automatic. So basically, when we make a decision to approve, we're liable for it. If we make a decision to decline, we hope that merchants see the value and decline it. So you don't need that layer. But what a lot of time you can do is, once we decline something, you can put it into a queue, get an alert, and then you can come, I don't know, when you wake up or Monday in the morning, see, well, Riskified declined all of these transactions, I can reach out to consumer, but you're not at risk from that order being approved and then, coming back and seeing the fraud, right? So there's that protection. We also have a lot of custom flows where we can, on behalf of the merchant, reach out to the customer with a branded thing and get extra validation. It's automatic, so it helps boost approval rates and decline fraud. So there's a lot of flows we've implemented over time to exactly answer these kind of challenges or needs of our merchants. We know that not everything is fully automatic.
Right. So thank you for that. We're coming up to time. So are there any last questions, Doug, that you've seen that's coming in that we need to ask, or is that all out?
Just a quick one. How can the audience get a copy of the Forrester report that you mentioned?
We'll, I think we'll just shoot out a follow-up email to the webinar and with the link to the Forrester report.
That'll be great.
Okay, great, thanks.
Thank you.
And this is my email if anyone has questions, and yeah, just shoot me an email and we can chat, and hopefully it was helpful for everyone here, and thank you.
Thank you, Al. Thank you, everyone, for participating. See you at the next webinar, which will be tomorrow. So thank you for your time. Thank you, Riskified, for participating with us on this webinar. Much appreciated. Have a good day, everyone.
Thank you, Art.